Welcome back. We are going to continue our series of how to write formulas and name ionic compounds. This video is on writing a formula from the name when you have an ionic compound that has variable charge. Okay, so the previous video we learned how to name a metal, nonmetal ionic compound when we have a metal with variable charge. And so a name would look something like 10(4) in Roman numerals, oxide. So we know that if we have a metal with variable charge, and lots of these are transition metals, that 4 in parenthesis, that is the ionic charge of 10. Okay, there's two charges for 10, but for this compound, it's 10(4). Okay. That Roman numeral is the ionic charge. So writing the formula is fairly simple because we know the charge of our metal because it's given to us in our Roman numeral. Okay. And then we know that oxide is the when you drop the ending of oxygen, it becomes oxide. So we have an oxygen, and it has a 2- charge. For our nonmetals, these do not vary. Okay, and so we learned in previous videos that oxygen is in group 6, so it forms a 2- charge because it wants to gain 2 electrons to have 8. Okay, for a formula to work and for the octets to be full and to be happy and for the ionic compounds formula's overall charge to be 0, we have to balance our charges, and that way we can come up with the formula or the subscripts for our formula. Alright, so we have two -2 anions, okay, so our formula here, we're going to need 2 oxygen atoms here, okay, because 2 times -2 gives us +4. Okay, our charges have to cancel, or they have to balance. So if you look here, our formula is 10, or SN1, understood 1, O2. The reason for that is we look here and we see that we need 2 oxygens in order to make our formula become +4. Okay, so it makes +4 -4. So we have 2 of these, +4, 2 times 2, -2 times 2, -4 equals 0. So we know our overall charge has to be 0. So some students can just look at these and do that and do simple, okay, if my charge is -2, I know I have to have 2 of them. That way I can balance out this +4 to give me 0. And so my formula is the element symbols 10O2. I'm going to show you just a little shortcut that I use, so you can do either way, but I look at the name here, and that 2 tells me that copper has a 2+, and then iodine's in group 7, which means it has a -1 charge. It's a halogen because it wants to gain 1 electron. So however you want to look at this, you can look at this and say, okay, I know I have to have 2 iodines so that my overall charge is 0, because that would be 2 - 2 equals 0. Okay, so that's fine. Another way you can do this is do what I call swapping charges. Okay, it's an understood 1, so I don't have to, I bring the 1 here, it's understood, and I bring the 2 here and put it there as a subscript. So that tells me for every 2 iodines I have 1 copper, or for every 1 copper atom I have 2 iodine, and this has to be the formula in order for my octets to be full and for my charge to be 0. I have zinc, 2. And oxygen, okay, oxide, okay, it has a 2 minus charge. Okay, if your charge is balanced, so 2 minus 2, that already equals 0. Okay, that means you just need one of each. Okay, so you don't have to swap these, because then you would end up with this, and that's not the smallest whole number ratio, right? We could divide both of these by 2 to give us that. Okay, so we do not write it this way. If it already balances, then you know you just need one atom of each. Okay, if you have whatever your numbers are here, but they're not the same, then you can swap your charges. Okay, and like you can also just look at them like we did on the previous slide if you would like, and see that if your charge is -2 or whatever that charge is, how many atoms do you need for it to balance out the charge. So here it's 4 minus 4 equals 0. So either way that you want to do this, but I seem to find students like to do the swapping of the states or swapping of the charges there. All right, I hope this helps, and I will see you soon.